Okay, hey there. So let's see if it works, and if it works, then we can get going. I think the camera is a little skewed as usual. Maybe now it's better. Now it's even worse. Okay, maybe now. Hi there. So let's see if I can hear myself. Perfect, I can. So that means you should be able to hear me now. If you cannot hear me, then it's probably not a problem on my side. Hi everyone, so I'm Gunvale Coldwind, and I welcome you again on my weekly hacking live stream. Today's topic will be, well, first of all, I have some random stuff to talk about, and then I'll look under the last video's comments what topic you guys proposed, and I'm going to talk on basically two of them. I did look through them before, so yeah. So okay, the usual stuff, and let's start with it. First of all, a shout out to Live Overflow as usual. If you're into CTFs and security, you should check out his videos. They're like youtube.com/liveoverflowctf, and he makes quite a lot of really good quality videos on basically security, capture the flag competitions, and so on. So yeah, go and check out his channel. Apart from that, I would like to thank you today, say a big thank you actually, to Disconnected. Disconnected is today's moderator, and he will be helping me with, well, basically mostly with, if you have any questions on, and you're on IRC on our YouTube chat, then just use his nickname. It's here, like down here written, and he will let me know on our voice channel that, hey, there's a question, and I'll be able to answer it. So thank you very much, Disconnected, for your help today. Yeah, and he's also like a CTF player. He's actually, I think, a captain of one of the Polish teams. And last but not least, the topic of a live stream. So there was some chat on our IRC just before this episode started about what will be today's topic and why is it announced so late? Why cannot I announce it like before? So it's like this. Currently what I'm doing, and this is not perfect and I fully realize it, is I'm like basically come back from work and I see what are the comments on the YouTube channel under my previous episode and what are the topic ideas I have noted. Select one of them and just like go live with it. I don't do any preparations. Now this isn't perfect for a couple of reasons. Well, first of all, mostly because you guys do not know if something I will talk about is something you already know, or maybe you could just skip the episode, or maybe it's something you should allocate time for because it's something that really interests you and you would like to actually see what's up. So I'm going to change it a little. Once I get basically what I want is I want more ideas from you folks. Like what is interesting for you? What should I discuss on the live stream? I can discuss quite a lot of topics if I have any expertise on them, and that's like if it's security related or programming related, I can cover some stuff. There's obviously stuff I cannot cover, but in the end I would love to get ideas from you folks to basically, so you tell me what is the thing which interests you. And the way I propose currently we do it is go on YouTube under, well, this episode, and in the comments leave your idea for the next topic. And I will, during the upcoming week, I will browse the ideas and select one or two and basically focus on them on the next stream. And I also put the ideas which I selected under the description for the next live stream when I schedule it a day or 2 days before it. So yes, the camera image is flipped. That's correct. That's true. That's because I'm usually saying like this is the right side and left side, but if the camera image is normal, not flipped, then it actually appears flipped since the camera is in front of me. Therefore, I decided to flip the image, which makes my face not look the way I usually see it. Well, actually, it makes it look like I see it in the mirror, but not the way you usually see my face. So, and the Christmas lights are on the wrong side, which is normal, I guess. Well, it will be normal from now on. Okay, so what are we chatting today about? Let me actually show you the comments under the last live stream, and that would be actually just 3 comments. So one thing which I will start with is I'll chat like how do we prepare for CTFs, and then I'll chat about a single binary mitigation, security mitigation, which is one of the basic the security stack cookie. I'll basically describe a couple of ways you can attack it. You can attempt to attack it. It's not always possible. It's sometimes possible, and it also depends on the way. On a couple of things. So that will be today's main topic. Now, there might be a question like there might be some viewers which actually are not familiar with a CTF. What's a CTF? So a CTF is a capture the flag competition. It's basically a security hacking competition. There is, if you actually go to ctftime.org, then there is actually a whole league, like a general ranking and so on, a global ranking of teams and quite a lot of CTFs. If you check out the upcoming CTFs, there is, this one starts in 2 days, and this one also starts in 2 days, and this one starts in 3 days. So there are quite a lot of CTFs nowadays. Like, I don't know, close to 100 every year, close to 100 competitions. These are all team competitions, and there are quite a lot of teams participating. If you check the full rating for the last year, and there's like this many pages of teams. And I'm actually the captain of one of the teams. I'm the captain of Dragon Sector, which was second in the world in last season. We were also second in the previous season, and first in 2014, and third in 2013. We didn't play before that. So I also have a team. I'm the captain, but I'm actually somewhat of a retired captain, since now the acting captain is Valis, and the team is also run with Redford as a vice captain. So I still play a little, but not full time as I did in 2014, for example. So, Disconnected, for example, is the captain of another Polish team. So quite a lot of CTF players I know do watch my streams. So how does usually a competition look like? So usually a competition looks like that. Categories of tasks like Jeopardy. If you know the tournament, the TV tournament, right? There are categories, and each category has a question, and for like $100, $200, and up to $500. And CTFs is pretty similar, except that these are not dollars; these are points, and these are not questions, these are tasks. Like, for example, you can have a reverse engineering category and then 5 different difficulty crack me's to crack. Or there might be exploiting category and so on. So that's what CTF is. I imagine that most of you do know what a CTF is, but I did, I think, notice a question about it on either IRC or the YouTube chat before. So wanted to make this clear. This isn't product placement, I just have a t-shirt from them. KrzaQ is actually a pretty cool Polish security news site, one of the 3 biggest Polish security news sites. I like it, yeah. Although it isn't product placement, just I happen to be wearing it today. Cool. It seems there is a question. I talked about heap exploiting heap-based buffer overflow exploitation last week. Maybe just take an easy to medium heap exploit CTF challenge and solve it. That's a good idea for a next session. So I'm not an expert on heap exploitation, but I don't usually do it. However, do put that idea in the comments under this live stream, and I'll consider it for next week. Okay. Basics. There's also an idea, basics of hacking web applications. Again, if you have an idea for the next stream, for the next episode, this show is done weekly, so yeah, we can do something next week and even next and so on, and this could be different things. Just put the idea in the comments, because I will, in 2-3 days, I will review the comments, I will check the ideas, and I'll decide on something, so yeah, just put it there. Cool. So the question was basically on YouTube, how do we organize playing a CTF? Do we play it in a physical location, like for example somebody's home, or maybe the dorm, and if we're on the university and so on? And there's also how do we recruit new members, and how do we test the people we are recruiting? let's start with the first thing, as in we're basically an internet-based team, as in we are not placed in the same location, with some exceptions, but generally we play online, which means everyone is at their own home and at their own apartment, and we communicate on IRC. We also have we're using actually Google Drive and Google Docs quite heavily. We have a spreadsheet with tasks for each CTF and an IRC bot, which if you update the spreadsheet, then you get a notification on IRC that, hey, like somebody claimed the task or somebody solved the task or somebody added a note to a task. And that's usually enough for us. Sometimes we also use voice chat, in this case Mumble, to basically work on a task together. Now, so that's basically, we don't get commonly together to play a CTF, but there are obviously two exceptions. Well, first of all, if there are offline finals that we travel to, for example, Insomni Hack in Genoa or DEF CON CTF in Las Vegas right after Black Hat, or some other CTFs in Korea and Japan, and we travel to them, then obviously we get together and play that because it's an offline CTF. Offline tournaments also exist if you're new to the scene. Now, apart from that, we sometimes, usually once in a year, maybe twice in a year, get together and play offline just because we happen to be we play together, not offline, like in the same place on site, just because we happen to be in a location for some reason. Last year, for example, we rented a house just after a competition we organized on the conference because I think like a day earlier, next day, began the DEF CON CTF qualifications, which we were not qualified yet for, so therefore we had to play it. And we rented basically a huge house and played from there for I think it was 48 hours. It was pretty fun and a pretty awesome experience. A year before that, we also rented like some huge apartment in one of the hotels in the capital of Poland. And that was also fun. So we try to get together at least once a year and do that because it's also fun. I know there are some teams which are, for example, made of students which are from the same university, right? And they are able to play in the dorm or in whatever room they have for example, for a computer club which they are a part of. So that's actually pretty common. It's from what I chatted, it's pretty weird for our team to be online based, but I think more and more teams like that appear. So it's not that weird. It's just probably you will find more teams which actually do play on site. How do we organize the play itself? Well, I did mention already we had a spreadsheet which is scripted, which means, so one of the problems you have during a CTF is that two people try to solve the same task and they don't know that the other person is also trying to solve it. In that case, you want to avoid it, so that's why we do have IRC notification that somebody claimed the task and somebody solved the task. It still happens rarely that somebody doesn't notice the notification on IRC, but we pretty much minimized it. So that's it. Apart from that, it's pretty organic, as in whoever feels strong about a given task takes it and tries to solve it. In the end, so that's the beginning of a CTF, right? If there's some tasks and they're usually rather easy and people start playing with them, even if there's a 500-point task, which are like rather difficult, if they're open, we usually don't jump straight to them because even like our top exploiters, for example, like to warm up first. Like, for example, grab a pawn for 100, solve it in an hour, and then jump to the 500 one just to warm up. After that, there is the period where we just, grab every task and solve it. And then comes like at the end, near the end of the CTF. And that could be actually like after the first 24 hours and only the half of the CTF still remains, but that's more like an end period usually in terms of CTFs. There are a couple of tasks left which we didn't solve due to either they're being complicated and we are actively working on them, or we don't have a good vector, like how to attack the task. And for example, we played Insomni Hack CTF teaser. I think I played it. It was beginning of January, well, more like 3 weeks ago or 2 weeks ago. And there was like a really simple task for 50 points, I believe, and we still didn't have any idea how to solve it, and we were just sitting in a couple of people on IRC and throwing random idea after idea and testing them. And finally somebody, I think there were like 5 people assigned to the task, and somebody says, oh, this is it, try it. And we try it, and yeah, it worked. So we meet in the end and try to focus on the task we didn't yet solve together and try to solve them. Unless we have the vector, then it's basically whoever is working on it, we trust the person to finish the task in their own pace. And if we ask, can we help you? If we cannot, then it's the end of a CTF for a given player. He can go to sleep finally. Though we do try to sleep during the CTFs, at least 4 or 5 hours. We find it easier to focus if you even have had like 4 hours of sleep. Now, one thing I wanted to mention about me showing, I had a chat about this on IRC today, and this is not uncommon. When I'm showing a task, for example, on a live stream, there's the impression that I'm doing this, and I get straight to the point, and then there's this like heap exploit which I just create during 15 minutes, and like a pawn task for 400 points gets solved in 45 minutes of a live stream, and it was so easy. And then I get people asking me like, how do you do it so fast? I mean, I tried for 8 hours and was not able to solve it, and you did it in 45 minutes. So please be aware that whatever task I'm showing, I'm usually noting that I did do the task before. If I did do the task before, I know exactly how to solve it. Therefore, I'm going the straight way to the solution, and I'm avoiding the usual process during a CTF. During a CTF, it actually could have taken me 10 hours to solve the task, just because, you start at the beginning, and then you, for example, check this vector, maybe it's this back, and you try to exploit it, and in this way, and in this way, and then you have to backtrack. And you get a binary tree, basically, which you have to traverse quite broadly to be able to find the path, which in the end leads you to the solution. But you waste quite a lot of time on traversing different branches of the said tree, where you they do not lead to the solution. And during the live stream, since it's only 1 hour, I do 1 hour live streams right now, I will show you the solution because I don't have time to show you the whole process. So that being said, it might sometimes happen that I will tell you that, hey, I have not seen this task, and it might take me a couple of hours to solve it. So yeah, just remember that the pacing of what I show is actually really, really different from the real pacing on a CTF. That goes really, really slow. And there are tasks on CTF which take, for example, 40 hours for 1 or 2 people even to solve it. So don't worry if you're taking your time solving a challenge. In the end, what matters is that you get the solution, right? Cool. Okay, there's a question. Hi, do any of your... So the question is from... I'm sorry if I read your nick incorrectly, it's Snis. Do any of your teammates use Radar instead of IDA? I wonder if it's possible to replace IDA and work with something else, like, for example, Radari, or I guess you could also work with Binary Ninja and so on. Yes, I believe sometimes they prefer IDA, but sometimes we try to use different tools as well. I know some people did try Radari, and I personally do struggle with Radari. I need to basically sit down someday and spend 5 hours with it, try to crack something with it, because the interface currently is not... I don't get it for now. Maybe at some point. That being said, so somewhere in the future, probably near future, as in, I don't know, maybe 4 or 5 episodes, I'll invite one of my friends, Karstein, to join me, and I know he's more fluent than me in Binary Ninja. He's been developing some plugins for it. So we'll basically, I'll ask him to show during the live stream, how do you go around using Binary Ninja instead of IDA, how do you write simple plugins, and so on. So I'll let you know when that happens. Okay, so the second part of the question was, how do we recruit new members? So, well, first of all, one of the things which is kind of unfortunate is that our team actually is Polish, and we try to recruit people who speak Polish. You don't have to be Polish, but you have to speak fluent Polish. The reason for that is that we did try, after starting the team, we did try running the team in English only, but we found out that not everyone in the team was fluent with English, and therefore the communication got, died down a little, and communication during a CTF is really important. So in the end, we had to basically trash the idea and go back to the native language of most people. So most of our candidates are actually speaking the same language as we are, same native language as we are, which which sadly means we don't do a really wide recruiting. We focus on people who speak the language, and then it's basically, we either reach out to the person who we believe might do good, or the person reaches out to us, and we ask them to play as a guest with us for an basically undetermined period of time, because in the end we issue an invite to our team, like an official invite to join Dragon Sector, after the person is shows us his technical skills, and that is usually demonstrated by solving at least 400 or 500 point task in a really technical category. For example, Pawn 500 on one CTF, and then Pawn 500 on another CTF. We usually require 2 CTFs in a row. And yeah, if somebody can solve like 500 pawn tasks, like low-level exploitation tasks during 2 CTFs, then that shows that the person is really good, and then there's an official invite. And it can be, it could be crypto, and could be anything which is technical, which means probably not recon. And what it boils down to is that every basically a couple of quarters, we look at the list, look who's doing best, and think about issuing invites. Sometimes we do it every year. But how it goes, it's not easy to get into Dragon Sector. I'm not saying it is. It's actually quite hard, because solving a 400 or 500 point challenge is not easy usually, unless you're doing this for half of your life or whatnot. Like quite a lot of people in Dragon Sector actually have been playing CTFs long before we created the team. So. Sorry, there's also another question. How do you deal with frustration when you get stuck with some challenge? There's some point where you stop trying stuff and always keep trying until you solve it. So yeah, how do you deal with, you're stuck with a challenge, what do you do? A couple of things. First, I try to restart the task. I basically create for each task I have a directory, like one folder on my drive. So I create a new directory with the same name, but _2 or whatnot, naming, and I try to start from the beginning, because maybe I missed something, and I try to restart like this 2 or 3 times, and then I try to write it down. If I'm out of ideas, I try to write down everything I know. In a document, like I would be writing an article, or actually if I would be writing notes which I can show to another person. When I write it down and I still don't have any ideas, then I grab a person who is free at the time from our team, usually on Mumble, and I show him the notes, and I start describing the task to the person. Now the person might have some ideas. I also, during the describing process, might figure out that, it might be actually it. Here's an idea. I didn't think about it before I started describing it to you, but now since I'm describing it to you, I have to crystallize the knowledge, how to structure it out in my head, and I've suddenly figured out of an idea. If that doesn't work, then and the person understands the task, then I sometimes pass the task to the person and ask him to solve it, because I'm just out of ideas, right? Sometimes the person will solve it, sometimes they will also don't have any ideas, and in the end, as I said, at the end point of the CTFs, we gather for all the remaining tasks and how many people are available, and try brainstorming basically the idea. So again, it's like when you're stuck, try restarting the task, and doing things in a little different way than you did in the first try, then writing down the notes, like detailed notes on what you know, what are the possibilities. Just list the possibilities for what is the vector of your attack, and then try describing it based on the notes to another person. That's like basically how I approach the challenge if I'm stuck. So yes, you do get stuck a lot, and that's a normal thing to get stuck. Don't worry about it. You just have to how to deal with it basically. Do you split the money if you win, or do you? We basically usually keep the money in one spot and use it to go to offsite finals, because, you know, in CTFs, unless you're PPP, I guess you don't really do a lot of winning as in monetary prizes. You cannot get rich on CTFs. No, seriously. And again, this is coming from a captain of like top 3 team in the world. So yeah, it usually goes for paying the bills, as in paying the flights to offline CTFs and offline events and stuff like that. Maybe creating T-shirts for the team. Sometimes you can get sponsors if you're lucky enough. I know some teams did get sponsors to go, for example, to DEF CON finals, to fly the whole team or like most of the team from some European country to the United States, and it's not cheap. It's like $1,000 per person for the flight itself, and then you also need the hotels. So I know some teams did get sponsors. Our employees, for example, in the past also helped us with this. So kudos to them, basically. Also, the universities sometimes, if you ask them, like, hey, there's this like competition, we qualified, can we go to the finals? Would we be able to sponsor us additional? Some universities will be able to help their students, basically. Yeah. Cool. So I think that's all I have to say about the CTFs and how it goes for our team, and also, you know, how it usually goes. So let's get to the next topic, which is more technical, and it's about cookies. Everyone loves cookies. So how do we go about it? First of all, let's see if I have if my Linux console actually spawns. It does. That did spawn, so perfect. So let's create a simple program with a buffer overflow and a cookie. And I'm going to use GCC cookies, but maybe let's start with it. So what's a cookie? You probably know what's a cookie already, right? If you're watching the stream, but just to be sure everyone is on the same page. So if you have a stack, for example, and ESP pointing to something, then usually if you're inside a function, the layout is the following. ESP points to usually local variables, right? And then after the local variables, there are some stored or saved, actually maybe saved registers. And after that, there's the return address, and after that, there are the arguments. And the story continues, as in, again, local variables, saved registers, return address, arguments, and so on. Now, a stack cookie is basically, so you know what happens if you if you overflow a buffer, which is a part of the local variables, you basically override this thing and you override the return address, which means that you redirect the CPU execution to either your code or some pieces of an existing code in memory, which you can use to do your bidding, basically, right? To do what you will. Now, in case of cookies, is like usually between the return, in front of the return address, there's also something called the cookie. Now, the cookie is supposed to be a random value that the attacker does not know. And just before the return statement, there's the return, right? The function exits. Just before this, there's a short snippet of assembly which does something like this. This is pseudocode, which I'm writing, obviously, or I can do it like this. If cookie is not equal, so the word cookie, let's say, is not equal the magical value. If it's equal, then whatever, red. Yeah, and if it's not equal, then call abort, oh my god, being hacked. And this function is supposed to basically exit the program in a safest way possible. Maybe print some message that, hey, I mean, the values on the stack, they're corrupted. Something has overwritten the cookie. It's not what it should be. Therefore, yeah, you have a hacker, right? Like in a, old hackers movie. I think we're being hacked. I think we have a hacker. Now, this is how a cookie usually works. Now, it's again, it's a random value. So the first thing, which is there's a question: what case stack will contain registers? Are there some calling conventions to preserve registers? So if you're talking about this, the idea is that in most calling conventions, there's a set of registers which can be used, for example, for arguments, right? If you have the fast call calling convention or the x86-64 calling convention, then you have the scratch registers, so-called, which you can just override with any value. And then there is the callee preserved group of registers, which means these are registers that should be preserved. Their value should be preserved when you, therefore, when you exit the function, the value of these registers should be exactly the same when you entered the function. Therefore, the usual way is to store them on the stack. You just like do push EDI, push EBP. EBP is a different case because that's a stack frame, but push EDI, push SE, for example, and then you pop them at the end. Yeah, that's basically it. So it's about callee preserved registers. That's when the saved registers are on the stack. Now, so there's a couple of important things here. First of all, this cookie, right? It has to be a random value. Therefore, there's the requirement that the attacker cannot know this value. Because if the attacker knows this value, right, he will just overflow this and then write the right value here, the correct value here, and then override red with whatever. And then we get to the basically to the compare, and the compare is, yeah, it's equal because the attacker put the correct value there, and we can return safely, right? We never call this, oh my god, I'm being hacked. So so the attacker cannot know it, and I guess that's the biggest requirement. And the second requirement is that the attacker should not be able to brute force it, meaning the cookie should be large enough for the attacker to not be able to run the exploit enough times to somehow suddenly magically guess the value. For example, the cookie cannot be 1 byte. If the cookie is 1 byte, then you just run your exploit 256 times and you get it, right? Like that's the probability for you. You will get it in 256 runs or give or take 10, depending on what method you actually choose and how's the output of the random generator. So the cookie must be should have good enough length and should be kept secret and generated in a safe way. Now, where's my browser? Okay, if you go to Vexillium.org, Vexillium is actually my previous computer club, let's call it like this. And if you go to /pub, there are some publications by me and Mateusz Jurczyk usually. So SPQ says that the cookie is not here, but the cookie is here. That's also possible. What I'm currently describing is like a generic way, which means there are a couple of ways to do it and a couple of ways a cookie is created. So both variants might be true. Yeah. Yeah, and there's something called exploiting the otherwise non-exploitable, as in, basically in 2011 we did with Mateusz Jurczyk some research on how Windows kernel generates the cookies. And there's a paper, this paper, which you can read if you're interested, is basically we analyzed how the Windows kernel for Windows drivers, how does it generate a cookie? As I said before, the cookie needs to be safely generated in an unpredictable way, so the attacker doesn't know it. And it turned out that the way it was generated, I think it was done on Windows XP, maybe up to Windows 7. No, maybe without Windows 7, or maybe even, running on Windows XP, Windows Vista, and on Windows 7. And it turned out that the way the cookie was generated was not actually correct. Now, here's the plot twist. On Windows XP kernel, the way cookie was generated, it was basically like this. Cookie equals constant. There was a constant, there was no generation. The cookie was always the same, and in every kernel file, it was always the same. So you basically knew the cookie, right? They didn't randomly generate it. You just knew the cookie. It was constant. I think it's mentioned somewhere here in the document. Now, well, usually in user mode, right, what you can do is you can do something like this, like, I don't know, for example, read from def urandom, for example, 4 bytes, right? And this gives you a 4-byte cookie, which is unpredictable. Now, the problem is that if you're just starting your operating system, then it's a little more problematic, because your dev urandom, your like cryptographically safe random generator, isn't yet initialized. I mean, you just started booting the system. There's nothing. There's just like the bootloader, and the kernel is just starting. How do you initialize the cookie for the kernel? And it's and for the drivers, which you need to really boot really early on, like start really early on in the boot process. And it turned out that they're using, for example, like the virtual address of the cookie, then the number of ticks from when the CPU was executed, and some other stuff. And it turned out that you could boil down you can predict most of these numbers. Being on the system, you could predict most of these numbers. And in the end, the entropy was about, you have had like 1.5 bit, which means basically every 3 guesses you could get the correct cookie. If you want the details, basically go to, again, I'm sorry about that. Vexillium with ILLI.org, and then publication exploiting the otherwise non-exploitable is the second publication. Yeah, and read the technical details. It was actually a fun paper. I do believe it's 39 pages, though we usually, when we publish something with Mateusz, it's quite long. So, and I believe there was also in the Android, for example, the operating system, the mobile operating system, there were also some problems with how do you get entropy at the beginning when you're just initializing your, running your operating system for the first time. Where do you get entropy, right? That's a good question. Okay, there's a question. Can I ask you or answer, how do we transition from Linux Pawn and being comfortable with today CTF changes to Windows real-world exploitation? That's actually a good question for Euro, since Mateusz is more dealing with Windows exploits than I'm doing it. So I'll try to pass the question. Please put the question in the comments to my video, and that way I will not forget asking Mateusz. And I'm actually should be able to talk with him about it tomorrow or so on, and answer you, or I'll direct him to you. Cool. So the question is also, is the cookie generated for every run of a program, every time you execute the program? That depends. It might be. Usually it is. I think on Linux, at least, the cookie is different every time you run the program, but I will actually get to it in a second, because there's a plot twist due to the way POSIX works. So yeah, so generating the cookie on Linux is usually okay. You can assume that the cookie is safely generated, and you probably cannot predict it in this environment. On a CTF, if you do see a custom implementation of cookies, you probably need to look on how are they generated, because if it's different than this, is like some custom or just using rand, which is a terrible idea, then you need to analyze it. That might be the case, but hey, I need to actually crack the way the cookie is generated. So this is just an example for how the cookie could be generated. It could be random, it could be rand. It's not the way it is done in any way. It's just a general concept which I have written down here. We can take a look on how they are generated on Linux. So let's actually do that. It seems I'm actually doing notes inside of a. I'm going to make a readme txt file and put it here, and this was the place I was supposed to write a simple KrzaQ, so it's just not KrzaQ, buffer overflow program. Yeah, whatever. I don't know, 200, maybe 32, and then we do freed to buffer and quite a lot of more data from standard input. Yeah, that's it. That should be enough for us to actually play with it. Now again, did anyone see my Linux console? Here's my Linux console, perfect. So let's compile it, and I do need yeah, it's fstack protector all. I think you can add some other parameters to it, but let's start with it, and let's basically put it in IDA. First of all, let's see if it crashes. And yeah, I need at least 32, obviously, and this should already crash it. No, but it needs to read the whole data, so... Sorry, how much again I'm reading? I'm reading this much, so okay. Out 256, A, and yeah. Yeah, and it terminated, right? Stack smashing detected and terminated. It doesn't display the whole report, but that's... So I'm going to get to this part. This part is somewhat interesting, and there's a cool trick behind actually abusing this, which if you're new to CTFs, you might not know. Cool, so how does it look in IDA? So let's just run IDA. 60. So this is a 64-bit version that I'm showing now. It doesn't matter that much. Yeah, the where's the... Yeah, but basically this part is checking this is where the correct cookie value is located, and it's doing a XOR, which is basically like if both the value of RCX, whatever is in RCX, and this is the cookie, as you can see, it gets it from the stack, right? Is exactly equal to whatever is the correct value of the cookie, then this will be jump equal, and it's okay, right? Then you leave, it's okay. Otherwise, it's stack check fail. This function gets called. And here at the beginning of the function, you can see that it actually does grab the cookie from the same address in memory and puts it in, well, IDA says it's a variable, but it's actually just the cookie, right? And it puts it on the stack. That's the most important thing here. Now, the one question is how is it generated? We can probably go to, if we go here to the start, is it initialized here? If it's not initialized here, we can either assume that it's initialized by this function, which is libc start main, or it's already there when the process starts. I actually don't know which one is correct, so we would have to, read the content of this function and find out, which we could do. Actually, it's good during CTFs, and not only during the CTFs, it's actually good to have source code of random open source software on your drive. And usually that's, for me, Python, PHP, and different versions of GCC, including glibc, which is, the C library version. I'm just going to look for this function, and it's here. Yeah, maybe let's do it like this. Sorry, could you tell me if the font size is okay? Can you see the fonts correctly, or should I maybe make it a little bigger? Yeah, this is it. I guess you'd have to analyze this function and see if it actually initializes the cookie. Maybe let's look for cookie instead. Pre-init cookie. Yeah, I don't know. Maybe it's in auxv or something, the cookie. But that's not the topic. We shouldn't analyze this and waste time on analyzing the libc currently, because that's not the topic of this episode. Cool. So how do you attack the cookie in this case? Well, in this case, I don't believe you could attack the cookie in any sensible way. Maybe there's actually one way you could do it. So But I'm going to need a Python program for it. So here's the thing. Let's assume, and again, a lot of things in hacking and CTFs are actually about making the correct assumptions and actually knowing what is executed. Let's assume that for some reason the challenge is on a remote server, for example, or is on a local server. And let's assume that the cookie remains the same with every execution of the program, which I will explain in a moment why this assumption is valid in some cases. And that actually this error is also, you can see this error, it's either redirected to the socket which you are connecting to, or if this is a local task, and this is actually a suite binary, then you can see this error on TTY for some reason. What you can see here is, actually the, the name of the application, right? So one of the things which are possible to do is, where does it get this application name from anyway, right? That's a valid question. Now it gets this name of the application from the stack, because if you run the binary, right? Let's just start it, and let's actually break it here. And if you start displaying the stack, I don't know, let's do it like this, and RSP. This is terrible. Let's try it again. Again, it's terrible. Maybe now? Yeah, that's a little better. I'm going to set height 0 so it actually doesn't. I can do this, yeah. Okay, and this is the stack, obviously, which I displayed for you, and these are actually the environment variables, but just before the environment variables there will be obviously the name of the application. I just have to scroll far enough to actually be able to find it. Yeah, it should be somewhere here. Actually the way the application was called. Yeah, I don't see it, but it should be somewhere here. Anyway, that's not important. It is here because, well, you know what arguments main gets, right? If you actually play with main, then it gets 3 arguments. That would be argc, then a pointer to pointer, an array basically of arguments, and then there's also the environment variables and p. So, and this is basically a pointer to things which are already on the stack. So the way which you could approach it is this would have to be a little more complicated program. Let's do it one more thing here. Let's do actually some. Let's just do. No, it should be actually fine. I don't know. Let's do a function anyway. And this function is spots. Yeah. And then we call this function here or here. Let's do here. Now the reason I'm creating this because this function will have its own cookie. So yeah, let's do something like this. Yeah. And this function will have its own cookie, and therefore what we can do is we can make, sorry about that. This again points to the stack, and there is like basically a pointer, right? And this pointer points to the name of the application, which is also on the stack, and in our case is like a out. Now, since we are actually overwriting the stack, right? After we finish overwriting the return address, we are still capable of going, and we can reach this pointer, obviously this pointer, but also the pointer to where the name is stored. If we change this pointer to point instead to the cookie of this function, because it's earlier on the stack, it wasn't overwritten by us, we'll be able to display the cookie, like leak basically the information from the stack, right? Which is pretty good. Now there are a couple of problems here. First problem is that ASLR might be present, therefore you cannot really overwrite the whole address here, but you can probably overwrite partial address. So that's one thing. The other thing is, I think that's the biggest problem. The other problem is that in case you do not have an fread, which is convenient for binary data, binary addresses, as in addresses having 0, then you actually do need to, and you can do only ASCII, 0 terminated ASCII things, then that complicates things a lot. But for the sake of discussion, let's assume this can actually be done. I think I could show you in GDB how to do it, but we have 10 minutes, so let's just, instead of this, let's do it in a different way. I'm going to do something else. I'm going to try to leak, instead of leaking the cookie, which might take me some time to actually play with the ASLR and so on. Let's compile it again. Let's open it in IDA again, and let's just write out a different address there instead of what currently is there. Okay. Oh no. Okay. Going to open it in IDA again, just to have the addresses. This is not ASLR, and I'm also going to, this is my basic script for basically running stuff on CTFs. It might be a little useful, but not fully useful. I don't need any sockets. Having like a, if you're using Pwn tools, then that's fine. I'm using just a custom script which has some functions which basically do the standard structure pack, structure unpack. So what I can do is I can do system, sorry, that's OS system, and run the application out with redirecting a file to it, and I need to write the file. Yeah, sorry, my naming is terrible. If you want to learn something about naming, like proper variable naming, proper file naming, it's probably you will not find this information on my stream unless I start doing programming streams about like production code, because technically I'm a programmer, so I do know how to do this stuff. I just know when I can ignore it, and now I can ignore it. And I'm going to write address here of what will be the address. So let's find some string, some random string. What, there are no strings in this program? No, you must be joking. No way. Strings window, and there's... Seriously, there are no strings in this. Okay, well... This is the only string IDA could find. No way. But okay. I mean, I don't mind. We can leak this. This is... Wait, it actually is ASLR. Do I need to disable ASLR to show you this trick? I can do it, because why not? KrzaQ. If you don't know KrzaQ, it's a really awesome tool to basically show you all the information about your... Yes, there is ASLR. We need to disable ASLR. So let's recompile it again. But no pi. Yeah, no pi. So there should be no ASLR now. Yeah, no pi, no ASLR. Perfect. I need to, again, decompile it in IDA. When you're learning this stuff, it's best to, play basically with one mitigation, security mitigation at a time. Okay, let's try it now. Same stuff, but yeah, this address I can use. And it will be what? Semicolon, asterisk 3, and a $. Not the best string in the world. Usually there are more strings in an application. Okay. Yeah, let's see if this actually works. Where's my console? Here it is. Python Pwn base. Right, binary. Yeah. This didn't work. Maybe I'm reading too little data. It might be the case, but you know, I'm reading only 256 data, but actually the name of the application is a little further on the line. We can try to fix it. Let's assume we can read like this much data instead. Recompile it. I'm pretty sure the addresses will remain the same, so I'm not going to load it in IDA again. And yeah, let's try this again. Yeah, and as you can see, basically instead of the A out, as previously I got an info leak basically, and again I could make this point to my stack cookie, and then you leak the cookie. This, however, this technique does have some prerequisites first. I don't think this is actually written. I don't think this message is written by default to standard error. This is written by default to the terminal, which means to, you know, dev/tty or whatnot. Which means that if you have a standard CTF setup where standard output and standard error are redirected to you, then by default you will not see this message. However, there's actually this message is displayed by this function, stack check fail. And it actually also checks for a variable name, which I don't remember now, but there's a variable name in the environment variables. If that environment variable is set to anything, then it actually outputs it to standard error, and you might have standard error redirected. And there's one more thing here, is that since you overflow the stack, right? And the environment variables are on the stack, you can create a fake environment variable of that name and be able to still leak data to you. So that's one prerequisite, and that's the most important one as well. The second one is that if I would leak the cookie now and I would restart my application, that doesn't give me anything because the cookie changes each time the application is run. And that's basically the thing which I wanted to talk about now. I think we have I'm going to make it the stream 10 minutes longer as usual, and just to explain the other thing. I think there are some questions, so let me... Why do I use vanilla GDB? I don't know. I mean, I don't mind. I don't use always vanilla GDB. It depends on which computer I'm at. I do use PEDA, for example, as well on my other computer, so I just don't mind using vanilla GDB. And I have some personal scripts as well. Though using like PEDA or PwnDBG is probably a better idea. I do agree with it. I just didn't ever feel the need to really use it. I heard that nowadays some production application stack cookies aren't present for some reason. Do you know the reason? I don't know. Good question. Maybe so. It's like this. For example, in case of Windows compiler, Microsoft compilers, there is one reason which I did put this, for example, this buffer, meaningless buffer in this function, is that if the compiler thinks that there is no buffer in a function, it might not add the stack cookie at all for the function. And there was like 10 years ago, there was Windows Vista, and it had a bug in the kernel. I believe it was the kernel or somewhere close in one of the graphical libraries for animated mouse cursors. And the library was stack cookie protected, but since the function actually had a structure instead of an array, then the compiler thought, hey, it's just a structure, I actually don't need any cookies here because you normally overflow buffers, which are arrays, but this is just a structure, right? Yeah, but you could overflow the structure, and it was exploitable just because there was no cookie there. So that's one reason. Another reason, if you completely disable it for production applications, might be actually performance, right? If you disable cookie checking, suddenly you have like 0.1% performance gain, or maybe a little larger depending on how many calls you have, how many checks you have, whether the cookie is in cache, and so on. So yeah. Okay, so the second thing, so again, I did assume here that the cookie is not changing with every run. Now, I did mention that sometimes it's possible to actually have a situation like that, and that's I did actually show on the previous on my previous stream, I believe, with, was it it? No, it wasn't it. You remember the CTF challenge I shown with a heap exploit and so on? That thing actually, I think, has exactly what I want to show about, so please give me 30 seconds, I'm going to find it. Roach, that was the name. Yeah, okay. And let's go here to the main function. Now, please observe, this is the main function, the main loop of the application, and please see what it does. It creates a socket, right? And then it binds it and does listen on it to accept incoming connection. And then there's an infinite while loop, right? And what it does, it accepts and it forks. Now, the fork, it doesn't do fork exec v to create a new process. What it does, it just forks. Now, what fork does, it basically creates a copy of the whole memory, which means that, and you start obviously exploiting the child, which is the forked version, and this infinite loop just continues forever, right? It enters the handle connection, which is the main function actually of this application. Now, what this means is that every time you connect, you get a copy, a child process, which has exactly the same cookie value and exactly the same ASLR addresses as on that. So if I could run my exploit once and leak the cookie value, then when I run my exploit again, then the cookie value remains the same because there is the fork. Between forks, just forks itself, the cookie value does not isn't recalculated. You would have to do fork and exec v to create a new process, and then the cookie value is actually recalculated. So keep that in mind. And there's actually one more interesting technique here. And this was, I believe, discovered or actually written about first by Ben Hawks, and then I think by Adam Zabrodzki in one of the FRAC articles. There's a technique which goes like this. So let's assume there's a cookie value. So where are my notes? Yeah, here. But the cookie value is like this: AA, BB, CC, right? And these are actually bytes. And DD. Now, and there's some data before it, and this is on the stack, right? And then there is the return address. Now, let's assume we have this forking situation, and you connect with your exploit, and what you do, you overwrite this, and you overwrite only the first byte of the cookie. And what do you overwrite it with? You overwrite it with 00. And what happens? Well, the application obviously crashes, right? It displays this stack smashing protection message if you're able to get it, or it just crashes, doesn't do what it normally does. Because why? Because the cookie is incorrect. The correct cookie was AA, BB, CC, DD. So what do? You connect again, but now you put here 01. It crashes. 02. It crashes. A0, it crashes. A8, it crashes. And you know, you increment by 1. And when you get to A9, it crashes. And then you increment by 1 and you get AA, and it doesn't crash. And you're like, hey, so the first byte must be AA. Then you overwrite it again, and here, instead of overwriting with a random value or AB, you just overwrite it again with AA, and you start brute forcing this byte. 00, 01, 02, finally get to B, finally get to BA, it still crashes. BB doesn't crash. That means the second byte of the cookie is BB. And given that the cookie would be, for example, 4 bytes, for each byte you have at most 256 exploitation attempts, right? And you have 4 bytes, so it's just 1024 attempts. That's not a lot. That's like 1 minute or 2 minutes of brute forcing with a decent network connection. So yeah, basically that's a good way to brute force it. If you have, again, you do need the fork. You need to have the fork, and you need to basically, it cannot spawn a new process. It has to be the same process with a cookie value. You can use this method to brute force the cookie byte by byte. So this is also important to remember. It's a good value. Good method to use. Cool. So is there anything else I could say about the cookies? Again, what I did show you today is I did show you the well, first, this funny technique of actually just changing the name, the argv0 pointer to leak anything on the stack. The second thing is this brute forcing, in case of fork, brute forcing byte by byte. Another way would be to, well, just leaking it. If you have a random or like a given address memory leak, or if you have any type of leak, like stack leak, then you can get the cookie for free, basically. That's pretty obvious, I believe, and it doesn't require too much talking about. Apart from that, one other thing is sometimes you do not get a buffer overflow per se, as in you don't get a continuous buffer overflow. What you get is instead you get, for example, you are able to choose the offset at which you write the value, and you just choose this offset and you write a value there, like a write what where, but you actually do choose the offset instead of from stack, instead of whatever is an absolute address, right? You choose the relative address, and you are able just to skip the cookie. You just jump the cookie. You never overwrite it. You never overwrite the saved register. You just overwrite straight the right address. That also happens sometimes. Sometimes there is, for example, some pointer here, and the local variables there's a pointer, and you overwrite local variables, then you override this pointer, and then the function at some point does the reference of a pointer and writes there. So you get to put an absolute address there, and for example, you know that the red value or a function, or actually you go for the IAT table, like the import address table, or the GOT-PLT, which is a global offset table / procedural linkage table. You just go for a straight write what where. You never touch the cookie. You end your overflow here, just overwriting the local variables. Now here's the thing: most compilers will try to actually put the buffer at the end, like near the cookie, so that you cannot overwrite any variables, but that does happen, so you need to remember about it. Cool. So perfect. Disconnected says that the variable name I was talking about is called libc fatal std_error. Yeah, like this probably. It's the environment variable. We can try it if it actually works. So let me run this again. Okay, and let's do an strace of the latter strace. And as you can see, the message goes to, yeah, it opens def_tty. It opens the console directly, doesn't output to standard error, and then it just writes the message to descriptor 5, which is the opened tty, right? But let's set now this the variable name export to 1, and let's do it again with strace. And as you can see, it doesn't open, it just straight outputs the stack smashing detected message to standard error. So thank you, Disconnected, for mentioning it. There's also a question from Christian. Do you know use Quira, as in Qira? That's the tool created by Giahot. Giahot, if you don't know him, he's basically a one-man army on the CTF scene, and he's sometimes also playing with the PPP, which is, in my personal opinion, the best CTF team in the world. He created this tool. The concept isn't new, but he did it in a so I'm saying the concept isn't new because my my bachelor's thesis was actually about it in all those years back. But he created a tool which was somewhat of a plugin to IDA and somewhat a standalone application where you basically record the whole execution of the application, and then you can make Kira answer questions like, hey, there is this address on the memory. Show me all instructions in the program which had written to this address, and based on that you can quicker understand how the flow of the application is going, and probably also write exploits in a simpler way. I tried using Kira once or twice. I think it's a valuable tool, and I would like to learn to use it more at some point. So yeah, that's basically my answer to the question. I don't think it's being developed anymore though. Okay, so it's on GitHub. Let's see. No, it was updated 5 hours ago. So there were quite a lot of comments. Let's see when the last comment was. The last comment was, well, a couple of months ago. So while it's not under active development, it seems they're probably it's probably way better than when I last tested it a couple of years back. So yeah, I think it's a good tool, and it's worth checking out. Also, just to note, GDB has an option to record the the application, how it goes, and also backtrack later on. But I think it's called like backward debugging or something, the term. But it doesn't have like a cool and useful interface as Kira does, and it doesn't sync with IDA and so on. So yeah. Are there any more questions? If not, I guess we can finish for today. Again, if you have any ideas for what I could talk about in the next episode, just put them in the comments under this video. Also, if you liked what you have seen, feel free to leave a thumbs up or subscribe to my channel, or tell your friends basically about it, because the more the merrier, as I always say. Yeah. Do I use Frida? Frida is basically a JavaScript-based binary injection tool, if I remember correctly. I didn't use it. I did hear good opinions on it. I might play with it sometime in the future. Yep. Okay, so yeah, let's wrap it up. Thank you very much for, well, staying late or actually waking up early, depending on the time zone you are actually in today. And let's, yeah, if you have, again, any ideas for what I could chat about next time, just put it in the comments. Otherwise, see you next week. Thank you to Disconnected for being the moderator today. And I leave you with it, and have a great day or great evening, whatever time zone you are in. Bye bye, see you next week.